Hello, we are back with our intermediate algebra course, and the challenge today is about radicals, because we are on chapter 7, that's about radical exponents. What number has its square root equals twice its cube root? So you know a square root is something like that, the index is 2, and we need to find a number that the square root is equals twice 2 times the cube root of the same number. Let's say n and n. What is n? Try to find using the knowledge that we have so far about rational exponents, and or you can guess at the end of this meeting, we will find the right answer. Okay, let's talk about section 7.4, adding, subtracting, and multiplying radical expressions. First, adding or subtracting. Look, we cannot split sums or differences. We cannot do the same thing as we have done with multiplication. Okay, what we can do when we are adding or subtracting rational expressions is combining terms, combining the terms, like combining like terms. We will combine like radicals. Let's work a few examples. We have to combine like radicals, and like radicals are the ones that have the same radicand and the same index. For instance, we have square root of 3 plus 7 square root of 3. Remember that in front of this square root of 3, we can add, it's here, it's invisible, right? We can make it visible, the coefficient 1. And what we're going to do is combine the coefficients. 1 plus 7, 8 square root of 3. Oops. And letter B. Look, we have square root of 2, 10 square root of 2 minus 4 square root of 2. This is square root of 2, and this is the same radicand, the same index. We can just combine the coefficients. So 10 minus 4 equals 6 square root of 2. What about letter C? Square root of 5 plus square root of 3. Well, both have the same index. It's invisible, but index is 2, right, of the square root. But the radicand is different. Look, this is 5, this is 3. We cannot combine. We keep this as 5, square root of 5 plus the square root of 3. And what about letter D? Square root of 2 plus 4 cube root of 2. Now we have the same radicand. Okay, the same radicand, but the index is different. Here we don't have anything, means is a square, and here we have the 3, means is a cube root. We cannot do anything at all. We just keep it. Square root of 2 plus cube root of 4 cube root of 2. Okay. What about this example? It looks like we cannot do anything because I don't see, at least I don't see any like radicals. This is a 27, and this is 75, completely different. And okay, we have the same square root in both. What we can actually do is we can factor out each one. If you manage to find two numbers that multiplied is equal to 27, one of the numbers is a perfect square. What we can do here is factor out each one of these numbers and try to find if we can write each number as a multiplication of one number that's a perfect square times any other number. 27 we can write as 9 times 3. 9 is a perfect square, right? And 75 we can write as 25 times 3. 25 is a perfect square. We can find the square root of 9, 3, and the square root of 35, 5. You can notice that now we have a like radical. We have square root of 3 and square root of 3. We can combine the coefficients. 8, oops, 8, the square root of 3. What about this example? We have 3 square root of 20 minus 7 square root of 45. Same thing because we can write 20 as perfect square, 4 times 5. And we can write 45 as perfect square, 9 times 5. See? So 3 square root of 4 times 5, 7 square root of 9 times 5. We can find square root of 4. 3 times square root of 4 is 2. And square root of 9 is 3. Nice. 3 times 2, 6. Square root of 5. Minus 7 times 3, 21. Square root of 5. Combine the coefficients. 6 minus 21 is going to be equals to negative 15, right? 6 minus 21, negative 15, square root of 5. That's the final answer. And another example. Let's practice a little bit more. Another example. Remember, we are working with square roots, so find if we can represent 75 as the multiplication of a perfect square, 25, times another number, yes. And what about 12? Perfect square, 4 times another number, and 3 we cannot break down, that's all. We find the square root of 25. Minus 5 is square root of 3. 25, the square root of 25 is 5. We keep this negative here. Plus, what's the square root of 4? Square root of 4 is 2. Minus 3 is square root of 3. We have the like radical 3, the square root of 3, right? And we combine the coefficients. Negative 5 plus 2, negative 3 minus 3, negative 6 square root of 3 is the final answer. Okay. Simplify the following radical expression. Since we have variables, we are working with variables, we are assuming that all the variables represent positive real numbers, so we don't need to be worried if they are negative, if they will cause some kind of a problem. But no, they are all positive, don't worry about it. Let's try to simplify. Basically, again, we will try, since we have square roots, find a number that's a perfect square. 9 times 5, then multiplied by another number is equals to 45. And we have this 3 square root of 9 times 5. And x cubed, we're going to break down in the same way. We have x squared, is a perfect square, times x makes x cubed, right? Plus x square root of 5x. See, if we combine x squared and x squared times x is x cubed. So we're going to break down the variable in the same way we've been doing with the numbers. Because now we can find the square root of 9 is 3. And we can find the square root of 2 is x. square root of 5x plus x square root of 5x. Now we have the like radicals. The like radical is the square root of 5x, right? And and we can just combine the coefficients. Okay. 3 times 3 is 6, 6x, 6x plus x equals 7x, square root of 5x. That's the final answer. Okay. We have another example. Simplify the radical expression, but be careful because now we don't have a square root. We're going to have cube roots. Okay. Pay attention because what's the cube root of 64? You know the square root of 64, right? Square root of 64, 8 times 8, 64. But now we're talking about cube root of 64. And is the number multiplied by itself again is equal to 64. Yes, it's 4. 4 times 4, 16 times 4, 64. And cube root of 14. We don't have a cube root of 14 is not a perfect cube. Minus 9. Combine like terms. Negative 5 plus square root or cube root, sorry, or 14. That's the final answer. Another example. We are working several examples to practice. Now we are back to square roots. Subtract. Assume that all variables represent positive real numbers. We don't have variables. We don't need to be worried about it. So the square root of 45, we can write as a square root of 9 times 5 over 4 minus a square root of 5 over 3. Well, a square root of 9 is 3, square root of 5 over 4 minus square root of 5 over 3. Look, now we have like radicals, square root of 5, square root of 5. The problem is just, is not anymore a problem of radicals, but a problem of rationals. We need to find the least common denominator. Between 3 and 4, the least common denominator is 12. And to have 12, I have to multiply by times 3. To have 12 here in the denominator, I have to multiply times 4. But don't forget, we need to do the same thing on the top of each one of the fractions so we don't change the ratio, okay? This is equals to, okay, 9 square root of 5 over 12 minus 4 square root of 5 over 12. And we can write, since they have the same denominator, 12. 9 minus 4, 5 square root of 5 over 12. That's the final answer. All right, next objective, multiplying radical expressions. You know how to multiply a radical times another radical, but now let's see what happens if we have multiplication with 2 radicals, 3 radicals added or subtracted, and we will basically have to use a property, distributive property, right? Distributive property. The square root of 3 times parentheses, the square root of 3 minus square root of 2, apply distributive property, then you have a square root of 3 times the square root of 3 minus a square root of 3 times square root of 2. And by property of radicals, the product rule, you can write this as square root of 3 times 3 minus square root of 3 times 2. Right? This, of course, square root of 9 is 3, and square root of 6. That's the answer. Letter B. We have a square root of 3 minus 8 times the square root of 3 plus 8. Look, you can use FOIL method, you can use distributive property, but there is a formula. I'm going to write down the formula here at the bottom. So if you remember, A minus B times A plus B. Oh, this is B. What? Equals, this is difference of two squares, a squared minus b squared. Okay? What we will identify here is a, and b, and the answer is going to be a squared. A squared is square root of 3 squared minus b. B is 8 squared. If you find a question with the parentheses and the square right here, that means this whole thing is squared. You're going to multiply this whole thing by itself. You can write like this, plus 2 times square root of x plus 1 plus 2. Okay, and you apply FOIL method. You can do this, first, outer, inner, last. Or another option. Both options you have the same answer. Another option is to use a formula, another formula. I'm going to write here at the bottom. A plus B squared equals a squared plus 2ab plus b squared. Okay, so let's identify a. This whole thing here is going to be a square root of x plus 1, and let's identify b. 2 is b. So equals a squared, so square root of x plus 1 squared, plus 2 times a, square root of x plus 1, times b, times 2, plus b squared. 2 times 2, 4. Simplifying, because square root of x plus 1 is squared, is just x plus 1, plus 2 times 2, 4, square root of x plus 1, plus 4. And finally combine like terms, and we have x plus 4 square root of x plus 1 plus 5. That's the answer that we are looking for. Now we finish section 7.4. You probably will have the answer for the challenge, right? What number has its square root equals twice its cube root? So square root of n equals 2 times cube root of n. Well, there are a few ways, a few methods that we can use. But I think the best, the quickest way is to try. We can try a few options, okay? A few numbers. First needs to be a number that is at the same time a perfect square and a perfect cube. Think about numbers that are perfect square first. 4 is a perfect square. 9 is a perfect square, not a perfect cube. Another one, 16, perfect square, not a perfect cube. 5 times 5, 25, perfect square, not a perfect cube. 6 times 6, 36. No, not a perfect cube. 7 times 7, 49. Not a perfect cube. 8 times 8. Oops, wait a minute. 8 times 8. 8 times 8 is 64. 8 times 8 is 64, is a perfect square. And 64 is also a perfect cube. Is 4 times 4 times 4, remember? So the right answer is going to be 64. 64 is the number we're looking for. Thank you for watching, and let's meet again with the next section.